Well, hi there. What's cooking, good lookins? We're just chilling like a villain. Give me just a second to get everything booted up. Shut up. And then we'll get going on our initialization. Give me just a half a second. Let me play some music. Study with lo-fi Miku hip-hop beats. Well, now we gotta see it. Now I gotta see what's going on. Okay, hold on. Let me just link this 1 second, guys. Hold on. Delete, at everyone, paste, copy, paste. Fuck, sorry, wrong name. Copy, paste. There we go. Okay, sweet. We did it. All right, let me just get mentally refreshed. We did not stream yesterday, and that's okay. You know, that's fine, right? That's all good. Let me just change one more thing here. Okay, good. Not lagging. Everything's gooch. All right. So this is our current initialization function. So under our main here, we're just going to call initialize. Oh. Auto what? Data is equal to that. Anyway, initialize. And then once we have that data, it can either be a string or it can be something else. It can be anything. It could be an app data or string. But we'll talk about that once we get a few more people in. We'll go over kind of what's going on here. I just did this on my own yesterday so far. Takes a little bit of time to figure out this unique pointer SDL window situation, but we're gonna get there. We'll get there together, chat. Hello, Silkwing Butterfly. How's it going? How's it going? All right, so let's kind of go over what we're doing here. Oh, let me just take a breather. You know what? I have grapes next to me. I'm gonna eat a couple of grapes because I'm hungry. I'm gonna go hang out with the former librarian today. And I wanted to eat before I go so I don't just wolf down food while I'm there. Ow. It's going good. I'm gonna just have like 2 more grapes. Let me just have like 2 more grapes and we're ready to start. What do I think of the redraw? You mean this? Hold on. Hold on. Hold on. So this was the old one. This was the original Gary the Goo Dragon, I believe. Actually, it's not, is it? This is part of the redraw, right? It's been a while since I looked at the Goo Dragon, but this is super similar to it. And then you have the redraw. Oh shit! Look how cute that is. I love it. It's adorable. Hold on. Okay, I'm done eating grapes. And that is the old one. Gotcha. That's cute though. I like it. Oh, little goo dragons. I think it's adorable. All right. Thank you so much. I appreciate it. Glad to see you in the Discord. All right, so let's go over our initialization thing that I did off screen or off stream yesterday because I was sleeping. So we have our includes for our SDL3 thing. I wish we could just do import SDL3, but I have to make a whole NuGet package and that's just a problem. So we're importing initialization. We'll come back to that in a second. We have our import standard library, which I don't even think we need. Oh no, we will, because we're gonna see out. So here's what's going on, right? We have our main function returning an int, normal, right? We're gonna have an auto data is equal to initialize. Well, what does that mean? Actually, we should call this. Oh no, we can't call this app data. This is here. What does that mean? So we have a module initialization, which is just beautiful, right? We're going to include our SDL3 and SDL3 header, and import standard library. We're gonna make a struct called app data. Our resolution's going in it, our renderer's going in it, and is there anything else? I don't think so. I think that's all we're gonna be returning. Anyway, this is where we get a little bit weird. This is where we have like a lot of modern C++ language here. Export, meaning that it's able to be used in another module like this. Export, auto, being something we put in front of every function now. Initialize, taking no parameters, returning a standard expected. All right, what is standard expected? Standard expected is a really, really cool error checking feature in C++. It's not something you want to run for really fast functions. You want them to run in necessary functions, like the game breaks if this does not load correctly. So what does that mean? We need, in order to do a standard expected, you have to return the data type that was supposed to be right here for the function. That's the expected data type. So we're expecting to return a struct. But this is our alternative. This can be anything. It could be an integer for like an error code. It could be an SDL get error, like whatever that is, right? Or whatever that returns. What does that return? Okay, whatever number that returns, if it's an error code or a string or whatever, right? So you have our standard string. So if something goes wrong, and we'll talk about unexpected in a second, if something goes wrong, we're returning a string when we call unexpected of some kind. In this case, we can't find monitor resolution, but we'll get back to that. But if everything works, its normal return type will be that struct. Does that all make sense? I hope it does. Basically, you use this when, if initialization doesn't work, fuck the struct. You just need to know why, you know? Like maybe you have a user playing your video game and they delete like SDL somehow, and they just get rid of it. Well, how would you know that? How would they know that? That's what a string is for. So what is the next line here? Auto DM is equal to SDL display mode curly braces. Oh, that's weird, right? This is oops, sorry. Those two are the same. This and this is the same. However, I am a big believer in always auto. So auto DM is equal to SDL display mode empty brackets to imply there's no value there, right? There, that's actually equivalent here. Or whatever, null pointer. That's actually equivalent. So what do we do with this DM? This is an SDL display mode, which is a object type that actually contains a lot of values. DM dot, we have a display ID, driver data, format, pixel density, refresh rate, width, height. It's your monitor, right? So I can check what is the refresh rate of your monitor and set the FPS to that, which is VSync. Or I could check your refresh rate and be like, okay, that's your refresh rate. Have half of that divided evenly, or something stupid like that, you know? So it always looks nice. Format, driver data, all that stuff, right? That is the SDL display mode object type, which is just a struct. Now, what do we do with that data? Well, we're going to be calling SDL get current display mode, and we're going to return. This actually changed. Oh, I'm sorry. This is one of those changed functions. I got to remember to like call out the differences between SDL2 and 3. In SDL2, the parameters looked more like 0, address of DM or something like that. It was like this. It was really weird. Whoops. And we don't do that anymore. What we call is just DM dot display ID. So that ID is what gets current display mode going. And that means all of the information about our primary monitor is actually going to be loaded into the DM display mode data type, right? So if I need, say, the width and height of your monitor for full screen, that is this resolution, right? I can set the resolution to the width and height of your screen based on DM. So that's why we set a display mode like that. So we check if this does not work or does not return the value we expect or something. Hold on, does this actually return false on failure? Actually, should check that. Display mode. Yeah, so UN32 with high refresh rate driver data. So this is the old struct because now we have a display ID. So that does change, but get current display mode. The display mode with the current display mode returns 0 on success or negative error code on failure. So what we should say, if this does not equal 0, then return this. That's what we should say, because it returns 0 on success. Oh, sorry. It loads this pointer, which is what DM is. It's just a struct, but it loads that point. Whatever. It's going to change the values of what we need to, right? If it doesn't equal 0, then we're going to return the unexpected value, which is a standard string, and we're going to return cannot find monitor resolution, which is really all we're going to use it for a while. Maybe we should say information. Maybe something like that. How about this cannot find monitor? Maybe that's a better way to put it. So anyway, we're going to return that string. And then what we're going to do is, because we're returning app data or string, this auto value can actually be multiple pieces of information. It could be a string. It could be a struct containing information. What do we do with it? Well, what we're going to do is, if data is equal to string. Oh, wait, this is a bad way to do it, isn't it? Yeah, that doesn't make sense. How did I do that now? Hold on. How did I do that back then? How did I check the data type? I want to do this as cleanly as possible here. What are we doing now? We are doing this. If, oh, right. That's weird. If explanation point app result. That's cool. If explanation point data. So if the data is a fail state. Oh, that's kind of cool. I forgot that was even a thing. Damn, C++. Basically, if data is the unexpected result, which is a string, you know, print out string. What are we doing now? Initialization. See out data. Wait, what's wrong with that? Hold on. Chat. What's wrong with that? IO stream? I already have IO stream though. Oh, app result error. Okay, sorry. There you go. That's your unexpected data type. All modern stuff except for printing that is still old school see out. Hey man, see out is a powerful thing, all right? Don't be dissing, all right? What are you, one of those nerds that's like, print F, fucking %, fuck your mom, upper C, boom, boom, boom. And then it's like %S. I don't know what you people do in C, okay? That's wild. But here's what's even better, chat. Print. Did you guys know that print is coming to C++ 26? A whole new print. The C++ 26 standard actually has print, which is a much better C out. And, oh shit, and better file reading. I forget what it's called, but basically to replace JSON files. It's like reading files is like it getting overhauled, which is gonna be amazing. All right, fuck making your own in-out, fucking print out a text file, print it in binary. I'm just probably gonna do the exact same thing, but we have a standard print line now and it's in 23, not 26. Oh wait, really? Not is printable, Jesus. Visual Studio. Let's see, print line, standard format string types argument void. What do you want? Hold on. I can use that? Dude, I can print line now? I didn't even know that was a thing. Print line, format string arguments. Oh. So print line, please. Print line enter. Password. Print line there. Valid since C++26. Same effect as print line with a space. Ah, or print line empty. Please enter password. Oh, it skips line for you too. Okay. So this could say nothing. And there you go. That's its own line. So if can I print data.error? Oh shit! Oh shit! I didn't know this was ready. Oh. Oh baby. Oh, we're doing it. Oh, hell yeah. Mind blown. Oh my god. And we're gonna return 1 so that way we know if we see 1 at the bottom there's an error somewhere. That's all I use that for. Wow, look at that. It's so clean. Run the program. It's gonna fail, but let's just run it without anything else here. It should blink on and off real quick. Oh, wait, what? Warning, unexpected tokens, expected new line. Okay, that's fine. Purview of module initialization appears erroneous. Consider moving that directive before the module declaration or place the textual conclusion with import header. Oh. So you're saying do that. Unexpected following preprocessor directive, expected a new line. Module declaration can only appear at the start of the translation. Oh, I was right. Fuck. Wait, so what's its problem here? Is it saying do the modules first and then do the that stuff? I wonder what the actual warning is for. Include in the purview of initialization appears erroneous. Consider moving that directive before the module declaration or replace the textual inclusion with import. I already tried that. I can't. It's not gonna let me do it. Oh my god, it let me do it. Wait. It didn't. What? Oh my god, that worked. Wait. I have to include the main file, but SDL3 header is fine? Why not just let me import main? Why not? Why can't I just import SDL3 and everything just work? Ugh. What? It's gonna make me call that with a hashtag include just for the main file, and then here and everywhere else I can import SDL3. That is wild. That's just silly. Oh my goodness. Okay, well, shit. I'll take it. All right, what's the actual error here? Basic format string character. Call to immediate function is not a constant expression. This is not a constant, so I can't print the line. Because import header file.h doesn't run preprocessor stuff. Oh, I probably should do that first then, huh? which is necessary for changing main function to SDL main function. Oh, thank you, Lucas, for the solid answer. I didn't know that. Failure was caused by a read of a variable outside of its lifetime. So this is something I think has to do with print line. It's expecting a basic format string. A call to immediate function is not a constant expression. Does this have to interact with standard unexpected? That's the only time you would ever touch this, is if data is a fail state, which is a string. I mean, I could do something goofy like standard string, local string is equal to data dot error that, and then give local string here. Does that work? It would take it. No, it's still a failure. Huh. I really want to use print line, but is it not, does it not like standard unexpected? Or is error not? Error is a string. It prints the error. Huh. Also, why is SDL destroy window empty and initialize? Oh shit. Oh, wait, you're right. The fuck? Wait, what? Wait, hold on. What did I do? Huh. Oh, that needs to go there. No, it doesn't need to go there. Wait, what did I do? It's a function. SDL window pointer. Yeah, that's right. Void SDL window. As standard function, do this. Is this not? Does it not have to be empty? I thought I must have done that for a reason and I don't remember. First argument needs to be context expression. If you want a dynamic data, you format it with that string. Do you want C string? Does it want a string? No, hey, hold on. If it's fucking C++23, there is no such thing as needing a C string, okay? No member C string, basic string. Standard expected. Yeah, so the data auto object knows that it could be a standard expected app data. Yeah, that goes into the variable. So this is dealing also with standard expected. So if this is unexpected, then print the error. But that's just a string. Can I just, maybe, am I just doing something else? Hello? Did we just do that? What the fuck? Hold on. Let's just unexpected on purpose here. I'm trying to think about how to fail this. Oh, here, I'll just return it anyway. Hello, what the fuck? Okay, so that is working. So just a regular string works, but this string doesn't. Why? SDL is a C library, not C++. Well, we're not using an SDL thing. Print line is C++23. Comma after create window. Oh, you're right. Oh, shit. That's why I did that. But doesn't it still need the rest of the parameter? I don't know why. We'll come back to that. I'm more concerned about this right now. So standard print line is like the only issue we have here. Because if I did like standard C out, whoops, standard, fuck, C out. Oh my God, Visual Studio. I'm just gonna turn off IntelliSense. If we just did that, that would work. It would print that message. Yeah, that just works. So something is going on with print line. Oh my God. There, something's going on with print line. I want to use this. I need to use this, okay? I need it in my soul. Print line, that data error? No shot that's gonna work. Failed because call to immediate function is not a constant expression. That is so weird. You would think like 2 of C++'s newest features that were released in the same fucking edition would not have this issue. Copy paste what I typed. Oh my God. What's the difference? It's the same thing. Oh, wait, what? Hold on. Okay, hold on. I don't fucking get it. I don't understand. Wait, how does string curly braces, comma, do this? Is this like a callback to like print from C? It's a format string? So if I do just blank, that won't work. Oops, oops. Hold on, edit, redo, redo, redo. Okay, let's try this again. Okay, that doesn't work. Okay, makes sense. Regular parentheses doesn't work. Okay, regular parentheses just prints the parentheses, but curly braces. Oh, everyone shut the fuck up. That works. Okay, well, now I know. Fuck me, I didn't know how print line worked, I guess. Instead of the stupid printf way of doing %d, %s, now all we do is regular curly braces now. Oh, well, shit. That's cool. All right, another way C++ is better than C. Gary, it's so verbose. Yeah, well, you're talking to a guy who does like auto L data is equal to app data, the object type, parenthesis, curly brace. Like, I'm an always auto kind of guy. Verboseness is like my thing. If %data is true, that means data is a null pointer, right? What would data error work in that case? It just did. Studer. So how do I fail this? I can fail window easily, but I don't want to open that can of worms yet. We got to go back to our standard function here in a bit. I'm trying to think about how to fail current display mode. I guess I could just make it equal 0. So now on success, return the unexpected. It should work. Yep, see? So the reason why, actually I didn't even need to do that. I knew that wouldn't work. Or I knew that would work. The reason why this works is because data is not just, you know, it's not just a string or app data, right? Expected returns a lot more than just what would be a traditional data type. That's why it's a slower solution, and you don't want to use it during needing to be fast functions, because it's kind of a slow operation. You're returning this entire thing as a data type. And here you're returning the unexpected. So you're actually saying, hey, something went wrong. I'm returning to you a string with this text on it. Figure out what to do with it. This data, if I were to highlight this, is actually standard expected app data, comma, standard basic string, whatever text was in it, right? That's the object type. Then if we use exclamation point data, what we're saying is, if it's unexpected, if that's the value you have in it, it's not app data, it's a string, then do this code. In this case, we're just printing the dot error on the object type standard expected, and that error has the unexpected cout code on there. C++ is really cool, okay? If the data is true, that means the data is a null pointer, right? Oh, I see what you're saying. If this is true, this code won't even run. And yes, I think you're right. I think data.error is a null is a null pointer in the event this is true. But if it's true, then it just won't even pass this if statement. I think this is all fine. I can't imagine it being any other issues. All right, we did it. Now what do we do next? Auto local data is equal to app data, the object. So we're just initializing the app data struct up here. We're going to be returning. Local data dot resolution is equal to 0, 0, the X and Y value in that rect. It doesn't actually have to be a rect. I could do something like int width or whatever like that. But for now, we'll just use resolution. It's fine. So it's 0, 0, dm dot width, dm dot height. So we're grabbing the current display of your monitor. We're saying the width and height of your screen is going to be the resolution of the game. Now, what do we do with that information, right? Well, normally, excuse me. Normally, this is what it would look like. SDL window pointer is window is equal to create, oh wait, fuck. SDL create window, something like that. That's like the traditional way, but it's 2024. It can't be a null pointer. It's a new object on the stack of type expected. The percent checks, or the parentheses checks against the underlying type it expects. I read a lot about the stack today. I don't know. I wanted like a textbook, maybe re-understanding of what the stack is. And then I just went down this rabbit hole of like recursive functions and like reminded myself why tail recursion is like the only source of recursion you ever want. Recursion in a function is like nightmarish. And then it was like, if you want to try this out, make a recursive function without using tail recursion that tells you Fibonacci numbers, and then do and then return the function as a oh, what did it do? It was add a counter in the function so you can count how many function calls there is, and it was like Fibonacci 5, 15 calls. It's like, oh, that's interesting. Fibonacci 45, the fucking trillions. I was like, what the fuck? Holy shit. What is that, like 3 trillion or something? It's like so stupidly high, and it's like, oh my god. Maybe it wasn't that high, but like that's how, maybe 3 billion or something like that. But it's so just, it was 3 billion. Yeah, no, 3 billion. Right. And then it was like Fibonacci 100 is like quintillion. You're fibbing? Oh, buddy, hold on. I got a textbook for you. Hold on, I'm looking for the PDF here. Was it this one? There it is. Okay, Computer Science 1. cse.unl.edu. Computer Science 1, Chris Bork, Department of Computer Science and Engineering. Okay, let's Control F. Recursion. Tail recursion, 205. I was reading a lot of this book at work. I just downloaded the PDF and just went away. What did I say it was? 205? Okay. Tail recursion. Writing recursive. Okay, so this is the function they did. So, and if an integer n is greater than or equal to 0 is the input. The nth Fibonacci number f of n. If n is less than or equal to 1, then output 1. Else, output Fibonacci n minus 1 plus Fibonacci n minus 2 end. And they were saying, this is really bad. Fibonacci? Yeah, same thing. Anyway, he talks about Stack Overflow, all that stuff. And then, where is it? Avoiding recursion. It's like, recursion is not essential. In fact, it's kind of nightmarish if you don't know what you're doing. So where's our examples here? Okay, so this is the exponential increase in recurring functions if you don't use tail recursion. We could talk about the stack, but that's why, you know? All right, where we got here? Okay. Okay, to put this in perspective, consider computing f of 45. 1.8 billion n equals 45. The maximum representable value for a 32-bit sign to complement Signed twos complement integer. Is that a typo? Executing at C, a C implementation of this recursive algorithm took about 8 seconds and required 3.6 billion function calls. And if we wanted to compute f of 100, then you would need 573 quintillion function calls. It took about 8 seconds for the program to run at f of 45, which is this, and he did it in C, which is this function. I just thought it was really interesting. I don't know, I guess you guys can try it. I was trying to make a pun, get it? Fibonacci. Ah. Anyway, I just learned a lot, or maybe I kind of already knew it just instinctually, just by working with the stack a lot. I guess I never maybe it's because I never ran into like an actual Stack Overflow problem in my entire life. Maybe I just knew to always account for. It's gonna happen one day, and I'm gonna be very proud of that day, but it hasn't happened yet. I never had a Stack Overflow error yet. And it was just like, oh, here's the danger of that. And because it's dangerous, because if you do not use tail recursion, which is returning the recursion value, right? Return Fibonacci n minus 1, not just in the else output, because you just that's bad, because you just add to the stack more and more and more and more and more. I caused a Stack Overflow inside of the compiler with recursive templates. Based is what we say your name is. Whereas if you have tail recursion, you call the recursive function at the end as a return value, like return Fibonacci n minus 1 or do whatever else you need. Then the stack just doesn't add forever. It just replaces that. It erases the function and then it puts on n minus 1. So you don't have like this Stack Overflow error. I just didn't know that. Really? I never put it into words. I just read that. I was like, oh, it's really cool how you can like a simple like Fibonacci sequence can cost 8 seconds in C. It's wild. Anyway, that was way off topic. All right, what are we doing here? We're gonna create a window pointer window that. So that's how you do it the old way, right? And then whatever other parameters you had there. Here's the thing. We're not gonna do that. That's too easy. What we're gonna do is standard unique pointer. Ooh, a new feature. We are going to be as memory safe as possible when we do all this, right? Especially when we get to fonts, which is just a nightmare of memory management. Because if you don't know what you're doing, you're gonna have just gigabytes of memory leaking every second, depending on how many frames your game runs, right? So we're gonna have unique pointers and shared pointers and wherever else we're gonna use. I will say in the tutorial, if you don't know which one to use, just use shared pointers for everything. It's not good. You shouldn't always do that. You should be using unique pointers when you can. But if you don't know, just use a shared pointer. You can't go wrong with it. The reason why you want to avoid using shared pointers is because they are... you ruin a lot of what's good about C++, which is very lean programs. Shared pointers are fat and they're ugly. Actually, no, they're not ugly. They're fat, but handsome. They're just really heavy object types. And if we're gonna be tossing around something a lot like a renderer or something, then we don't want it to be a shared pointer, right? We'll just rather have a unique pointer. So what does this do? We're gonna have an auto window is equal to unique pointer window all this. Now, before we even proceed, let's just look at this one line. Remember, this is the context that we were working with before. Auto object name is equal to object type given value, okay? That's like the thing we're going with, right? Auto object name equal to object type empty value or whatever value it is, right? That is what we're working with. So auto window is equal to object type value. I think that's the, actually, no, it's not even that. I'm so sorry. Object type, that's the object type. Is that the object? Wait, yeah, that is the object type. Just what I've highlighted exactly. No, I lied. That's the object type. So this can be a curly brace. Okay, let's keep that a curly brace. That'll make it less confusing. Gotta remember, like, I don't want to swap when you use curly braces or just regular parentheses. So it's the same thing as before. It's auto object name equals object type value, right? So auto object name window is equal to object type value. It's the same thing. So what's going on here? Why is this so much longer? Well, we're going to use a autonomous function to do this correctly. Now, let me kind of explain why we're doing all this. If we were to do standard unique pointer SDL window 2. Okay, what's wrong with this? What's wrong? Well, in this case, it'd be a null pointer. Well, no, it wouldn't, whatever. In this case, what's wrong is that when we toss over this to any other context, like creating a window, we have a bit of a problem. Const character pointer, int. Yeah, so that's applying to that. Now, if we were to do window 2 is equal to this same value, what happens? The answer is it fails because I can't convert a unique pointer SDL window default delete SDL window equals SDL window pointer. It's a C-based library. We have to spell it out to the library. What does it mean to be a unique pointer and why is it okay to use in this context? So we have to solve that problem another way. So I almost wonder if it's easier if we kind of switch around the values here. This might be the one time we don't want to use auto for readability, because what it should be is that more clear about what exactly we're doing? You guys think? Like, of these two, which one is more clear? To me, the second one is more clear. But maybe like newer people would find the first one more clear. I actually don't know, because I'm thinking auto window is cleaner because you know what's happening right away. Oh, we're making an object called window and making it equal to that value. But this is more clear about what exactly is going on. The ban auto club? Oh, fuck you! Hell no, we're gonna use auto all everywhere, baby. Now, to be fair, in my world, if this were just a project on my own, I would do something like macro define func auto or something like that, where now we can define these as func values instead of autos for function names. That's how I would do it. Right? That's what I would do. But people hate that, so I don't. I've never been allowed to use auto. Why? Auto makes things so much cleaner. I would rather have the second one than the first one. Anyway, oh, but let me get back to the point here, right? So anyway, we have our object type, which is auto. Window is equal to, this is the object type. So why is the object type so long, right? I'm an enjoyer of define let auto const. Based? How do you, but if you don't want it to be const what the fuck blub, isn't that gonna be like very verbose? But maybe that's good. Maybe you want it to be verbose to make it not const. Based. Anyway, auto window standard unique pointer. So same thing as before, right? Normally, if we just did that, the whole program would shut down. It wouldn't even compile because create window SDL needs more definition. So what are we doing here? We're gonna call a standard function, which is the older way of doing what's called an anonymous function or autonomous function. I think it's anonymous function because you don't have the name for it. It's unnamed. We're making an anonymous function. This is the older way of doing it. We probably should do a lambda expression, but whatever, maybe not. And we're gonna call void and the parameter being the window pointer, right? Anonymous, thank you. Now, this double thing here, all that is you have the unique pointer arrow, which is here, and then you have the standard function, which is returning void, and it's using SDL window pointer as a parameter. So what we're saying is, hey, C SDL library, C base library, whenever we call unique pointer SDL window as a parameter, what we're really tossing over is an SDL window pointer with these added like functions to it, right? First, we're gonna create the window, right? This is now an acceptable function. SDL's like, all right, cool dog, you've already defined it with a standard function. I'm okay with it. And then we're gonna call SDL destroy window. Now, comma, destroy window. Because remember, this is just object types. That's all we're doing here. Remember, oops, here, let me do this all in one line and you guys may understand what I'm doing here. Remember, we just made an autonomous function saying void SDL window pointer, right? So, void SDL window pointer as a thing. I think that's why I did that. Maybe that's not even viable, but I feel like I did know I couldn't do this or something, right? Because it's implied in the standard function that this is this object type as a parameter, right? I think, oh God, I haven't fucked around with this in so long. We should just make this a lambda expression. I don't know, fuck. Define true ran. Oh yeah, is that what you're gonna do? Jesus. Oh, by the way, I wish we could do that and we can't. Auto, you can't do that. Using requires you to know the object type of auto here, so we have to use a macro if we're really gonna do that. Fuck around and find out, maybe try debugging? Yeah. Anyway, that's our window. So now we're gonna do the same thing to the renderer. By the way, this runs, right? Yep, there you go. Success, code 0. So this is now created. Beautiful. Now, we'll test if this is actually destroyed when we go out of scope of initialize. We'll come back to that later, but for now. Boom, 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 boom. Okay, so we're gonna be creating a renderer the exact same way. We're gonna make a unique pointer. We're gonna call SDL renderer. We're gonna make a standard function, void SDL renderer pointer, curly brace, not parentheses, make it consistent. We're gonna create a renderer using the window. This also needs a const character pointer, which is a string in C, but they choose to make it really complicated. I think, just going off of my memory here, that const character pointer is a flag, right? This is SDL renderer. Oh, accelerated is gone. You can't do that. It's just error. So the Lazyfoo tutorial is already out of date. So SDL renderer, what's the flag here? Oh, did they change the name? Prop renderer Vulkan. Oh, that's right. They added a bunch of Vulkan support. Oh, that's weird. Is it prop renderer? Why did they change that? Get renderer properties. Create name string, output color space. Flush renderer. Oh, we're using flush renderer later, by the way. Okay, so hold on. Let's look up the flag here. I should be super careful. SDL3. All right, create renderer. SDL3. Beautiful. Which is under heavy development. API is changing. SDL2 for stable version. All right, create a 2D rendering context. Window, character pointer, render flags. The name of the rendering driver to initialize, or null to initialize the first one supporting the requested flags. Ah, it's a null pointer. The last one, the UN32, that's the flag. 0 or one or more renderer flags ORed together, which is a bitwise OR, right? Okay, what are some of the flags? SDL3? If you want a specific renderer, specify its name here. So like Vulkan or something, right? A list of available renderers can be obtained by calling SDL get render driver multiple times with indexes 0 to that. If you don't need a specific renderer, specify null and SDL will attempt to choose the best option for you based on what's available. All right. By default, the rendering size matches the window size in pixels, but you can call set render logic presentation to change context size scaling options. So this matters if you do something like an RTS game. So if you have like a little mini map in the corner and you don't, if you have a little mini map in the corner, you don't need your render like engine or your render engine. You don't need your renderer to render that always. That you could use what's called a viewport. And I think that's where you would change the resolution of it. Render clear, render clear. Where's my, there's our initialization. Renderer, SDL create render. Oh, I need to initialize too. Oh shit. Go back to that in a second. Create window. Look how much simpler this is if we don't have error checking. Renderer is equal to create renderer, win, null, 0. Oh, is it that easy? I mean, I guess I don't care about any other contexts, right? So window is already known, right? Can I just delete this? Oh, whoops. It might help if I delete that. So now we are needing oh no, it was window. I'm so sorry. I'm dumb. It needs an SDL window. Unique pointer. Huh. Reference to window? No. How do we create a renderer from that window? I thought that would automatically account for what we need. Oh, wow. What the fuck, Blub? All right, what the fuck, Blub? What do you do for a living? All right, you son of a bitch. What do you know everything we're doing so far, and I feel like you are hella computer scientist, and you're not really, are you a data scientist? How the fuck do you know like all the modern shit in C++? Okay, to be fair, unique pointer is like 10 years old, but still. Comma, SDL, destroy, renderer. There you go, beautiful. I have been coding for over 10 years. Damn, you know your shit. I never would have guessed .get. So what other unique pointer shit can you do besides .get? I wonder what else you could do there. Let's look it up. I say look it up like I've never looked at C++ reference before, but bear with me a second. Ah, that's the wrong one. That hurt. Okay, that's our window. Where's OBS? Hello? There we go. All right, let's look up unique pointer on C++ reference, see what we're missing here. Let's see, release returns a pointer to the managed object and releases ownership. Reset replaces the managed object. Swap it. Get returns a pointer to the managed object. Ah, so that's how we're able to grab window. We're actually using get to call the pointer to that object. Gotcha. Sweet. Get deleter returns the deleter that is used for the destruction of the managed object. Okay. Operator bool checks if there's an associated managed object. Oh, so you can just check to see if that's even there. Okay. Dereferences the pointer to a managed object. Provides indexed access to the managed array. So it's a unique pointer array type. Make unique creates a unique pointer that manages a new object. Okay, sweet. Removed in C++ 20. Huh. Outputs the value of a managed pointer to the stream. Specializes the swap. All right, cool. So that just grabs the pointer. Sweet. So what do we do next? Well, after we have the renderer and the window, now we need to actually do something. Now, can I do, I don't know if this is allowed. Can I do if this does not equal 0? No, I can't do that. I can't have like a nested loop, right? Yeah, that won't work. So now how do I check if this actually loads? If window dot operator bool equals false, or whoops. What's the... This is obviously not the correct thing to do here. Oh, there we go. Equals false. Is that what I'm checking? Is that how you'd like error report this? And then you would standard unexpected cannot, oh, whoops. Cannot load window. I mean, that would work, right? Was the object bool thing I asked about before with exclamation point data? Was the object bool the thing I asked about before with exclamation point data? Oh, you were talking about this? I don't think so. I think this is a different thing. You check it the same way you check the expected. So if, oh shit. Oh my God, I love C++ so much. Every time they taketh, they giveth. I'd like to point out, by the way, that C++, the only reason it's this verbose in this exact circumstance is because of the limitations of C. I just want that on the record, okay? If I had my own homemade renderer, this would not be a fucking issue, by the way. Interesting. So if this is untrue, then do this. Wow, that's so cool. So that doesn't need an error check. This is fine. Window, check for the error. Renderer, if renderer fails to load, then standard unexpected failed to load render engine. I shouldn't say render engine. I should say renderer. Failed to load window. Failed to locate monitor. Monitor? Okay. This runs. Beautiful. All right. So now what do we do after all this? Well, we're not done. In fact, there's a little more we have to initialize here, because before all this, we have to SDL init, and we're going to be initializing SDL video init. SDL init. There we go. Now here's the thing, right? Gone are the days in SDL2 where you could just init everything. You can't do that anymore. You have to actually initialize individually every subsystem you want loaded. You can't get away with that anymore, which, gonna be honest, I used it. It was nice, but we'll just error check all of these. It's better, because what happens if like a user deletes a random fucking SDL DLL file or something, or a random header? Then, you know, you want error checking for that. So what we're gonna do is we're gonna initialize video. That's all we're gonna initialize. And then this is not done, because we're gonna go if this should return 0, so not equals 0, then do something. Let's double check that though. I think SDL initialize returns 0. Initialize the SDL library. Define an SDL3 flags, subsystem initialization flags. Return 0 on success or a negative error code on failure. Call get error. I'm not gonna call get errors. Okay, we're not doing that. Simply forwards the calling init subsystem. Therefore, the two may be used interchangeably. Although for readability of your code, init subsystem might be preferred. You know what? This function and init are interchangeable. I like the idea of an init subsystem more. Okay, I ain't gonna lie. I already used the term subsystem when talking about what to initialize. I like this more. This is more clear to me than just a init. It's an initialization function, obviously. So like, I don't have any problem being verbose. Okay. So if that does not equal 0, then what's the error code? We're gonna return standard unexpected failed to initialize SDL video. There, and I need to return these as well. My bad, a little bit of a bug. Okay, is there any other? God, this is such a long initialization function so far. So what are we doing here? Let's just keep this in order, right? Initializing video, grabbing the display information, making a window based on that display information. Actually, I'm gonna delete that for a second. That'll go at the end, I think. The reason why is because instead of L data here, I can just do dm.width. Oh, no, I'm not gonna do that. I'm not gonna do that because that doesn't give me the chance to, this, if I wanted like the width of the screen divided by 2 or something like that, I can change that here rather than like doing something else and then adding DM here. I thought about doing DM directly, but now I remember why I did that. Operator bool basically lets you treat the object as a bool type. Oh man. At line 15, you have an empty statement between the curly brace and the semi based on line 25. At line 15, you have an empty statement between the curly brace and the semicolon. You need a semicolon there, don't you? Oh, shit. Chat, why did I do that? God, fucking C++. Okay, listen, that's not C++'s fault, okay? Remember, oh no, I do need a semicolon. Chat, you lied to me. These do need semicolons. I was right. Line 25 is needed. Yeah, because we're initializing an object type. Otherwise, these wouldn't need semicolons. So yeah, we need one there, right? Maybe for readability, we'll do something like this. There, is that good for readability? I guess so. It is one line. There you go. That's readable, right? I think so. It looks readable. Okay, let's do that again. We're gonna keep that on a separate line because of the really long if. Sorry, I thought 25 was the end of an if. Nah. Nah. We're good, we're good. You were right about 32 though. Good to see you using brace init instructors. Yeah, constructors. Yeah, basically, ooh. No, that is a function call. That is actually the perfect example about why I do that. It's because when I use parentheses, I feel like it's a function I'm calling. Whereas if I do auto DM is equal to this object type, curly braces, I know that's an object type. But if I do like this, that to me looks like I'm calling a function, which is not what it is. We're initializing a value. Yeah, whenever I think curly braces, in this context, I think of initialization. That's what I think. The paren issue is that it can parse as a function declaration. Yes. Your way of describing things is better. Yeah, basically. Also, Joe, hello. Is there anything else we need to do? We have our subsystem, we have our display mode, create the rect, create the window, create the renderer, error checked everything. Is there, I mean, should I have all my initializations right now? Just for the fuck of it? Nah, we'll come back later. We're gonna have to initialize video. This, by the way, will be copy pasted like 8 times by the end of the tutorial. All next, it's gonna be like boom, 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 except it's gonna be video, audio, text, or TTF, fucking, fuck your mom. It's gonna be just wild. because we don't have init everything anymore, which is fine. Which can cause awful issues with mutexes and threading. Oh, baby. Wait until we... Oh, yeah. I'm sorry. This is going to be different than other game projects I've done. Just to be clear, we are going purist ECS, okay? We are going absolute fucking balls to the wall, purist, gatekeeping as a motherfucker ECS, okay? The reason why is because if we're doing multi-core shit, having pure ECS makes it indescribably easier and probably significantly safer. So we're gonna be hardcore ECS because SDL3 takes care of multi-threading, and we might as well, you know, use it if we're making a tutorial on it, you know. You can make your own functions to initialize everything, maybe using a loop. Yeah, we could. I don't see the need though. I might as well just copy paste 10 times. If it's chat, we're only running the initialize function once. We might as well just have it copy pasted here. It's ugly, but I mean, it's readable. All right. Anyway, cannot initialize. You know what? I'm actually going to spell that out. That way I can just copy paste it if I need to look for the number or the enumerated value. Are we just going to return app data now? So app data dot renderer is equal to renderer. What's wrong here? App data dot renderer dot get what? Expected an identifier. Wait, what? Am I retarded? Oh, this is local data, not app data. My bad. Okay, sweet. Now, chat, I have a question about unique pointers, so pay the fuck attention, okay? Just to make sure I'm not gonna fuck everything up, okay? We have a struct we're gonna be returning on success of the function of initializing, right? This will have a renderer pointer renderer. Do I need to make this a unique pointer, standard unique pointer, all that shit in the struct, or is this enough to carry this information? Because I'm thinking this might have to be a standard. Unique pointer is for ownership. It needs to be a unique pointer. Okay, thank you. I'm glad you understood what I was asking. Unique pointer, SDL renderer, that. What? Expecting a greater than sign? Oh, there we go. So it will own the renderer. Gotcha. So what we're saying is that at the end of this initialize function, when we return, what's wrong here? Oh, wait. It needs to be the exact same, including having the delete function. Holy shit. Fucking based. Okay. Auto renderer is equal to this value. Oh no, how do we do the window? I mean, I guess I could just throw the window into the app data. It's not that big of a deal, right? Also, it's not allowed here. Oh shit. This declaration has no storage class or type specifier. So what am I missing here? Only the type, not its data. It needs to be the exact same unique pointer, including the delete function. Just take the type, put it into an alias, name it something like renderer pointer or something. No, it's a unique pointer, right? That's why it's only one thing can own the unique pointer at a time. That's why I want the renderer to be a unique. Wait, do I want the renderer to be a unique pointer if we're doing multi-threading? Oh shit, hold on, wait. If I'm doing multi-threading, is that safe to have that as a unique pointer for the renderer? Well, yeah, it is fine, right, Joe? I think so. It is safe. Okay. What the fuck Blub has been doing this for a living, so it does need to be a unique pointer, only the type, not its data. So we don't need... We need this. This is the type. So then we just say, is this just renderer? Okay, there we go. Beautiful. So do I need to pass along the delete function? Because you said even the delete function. That makes me think that I have to have it there. But this works. Wait, does it work? Oh, I guess I can just do renderer now, huh? No, it doesn't. Inline is a deleted function. It is a deleted function. Oh shit. Move renderer. What? Move? Oh, because we have to explicitly tell the system, hey, this is a unique pointer, and now we are moving it to this object. Okay, Jesus Christ. Chat, it's not even C++. This is nobody's fault but my own, by the way. I just have so little experience with actual use of unique pointers because you can't copy it. Ah, that's the whole point of a unique pointer. Oh my God. Okay, based. And now everything works. So that's all I need for the struct, right? So now, in any point in the future, I ever need a renderer like SDL render copy X, I would just call... Oh, right, it was renamed. Oh, they have renamed stuff in... Oh, what? Renamed SDL render texture row? Oh, they have renamed shit. All right, good job, SDL, damn. Or maybe it's a Visual Studio thing. So render copy F. Okay, this is also a rename. What the fuck? Render text. Oh, render texture. Really? Yo, SDL, look at you. So now, in order to do the render texture, I can do ldata.renderer.get, and that calls the... Okay, sweet. That's awesome. So now, okay, now I know. End the window, right? Or is that part of the renderer? Oh no, Studer. Oh baby. We're freeing the window. In fact, I don't even, before you'd have to explicitly call SDL delete destroy. SDL destroy. Oh, it's right there. SDL destroy window. And you would destroy the window. That's how you do it before. However, you may notice we're probably not gonna call that. Or whatever, window dot, fuck. God, fucking zoomed in Visual Studio. We would have to call this before and destroy the window because we're done with it. Like once you make the renderer, we don't actually need the window anymore. We do have the resolution of the screen, but the renderer now already has the window from this function and we're done. That's it. Now chat, if we were to just return L data, if we just ended the function there, window would destroy itself, right? Because the scope of window, this function currently owns it, initialize. So it should call SDL destroy window when we return out of the function. Yes, okay, beautiful. God, I love unique pointers so much when I know what I'm doing. Oh, by the way, when you get into doing threading for race condition handling, it might be a good idea to enable thread sanitizer later, but that's a later issue. If we do pure ECS, like obnoxiously so, are we really gonna have any issues with race condition handling? Thread sanitizer doesn't exist on Visual Studio? Well, that's what I get for talking out of my ass, because I had no idea what he was talking about. All right. Okay. I use Clang GCC. I don't know, can you do fucking SDL print line? Or STD print line. They only implemented the address sanitizer. Okay, so then what I should do to really test if everything worked is SDL SDL print. Wait, what was renderer, right? Data dot renderer dot. It's not loading the data. Save it. Save data dot renderer dot. Okay. I just want to know what to type there. Okay, what do I got here? Release, reset, get deleter, unique pointer, delete. If I do that, that doesn't work, right? Or no, this works. Chat, I got a question about unique pointers again. If I call this line renderer, then tilde unique pointer, this is implying we're running the destroy, right? Which is destroy renderer. That's what that does, right? It might as well be SDL destroy renderer, but we're explicitly saying, hey, this unique pointer, destroy it right now before you even end the scope that it's in. I think that's what that means, but I don't know. Okay, sweet. I like it. So now what are we gonna do? How do we test this? I guess we can just run a simple like function or program. Does it even run? Beautiful, beautiful. Okay, excellent. Now I kind of want to fuck around with it, like destroying windows and all that, but it's fine. We'll assume I'm correct. What better way to program than not test your code? Chat, do we get obnoxious with this and do like 100% testing and all that shit and fuzz and all that crap? Like, as a beginner, not even a beginner, that's the wrong word, is somebody who is learning SDL3 with C++, who knows C++, are they gonna want to like know about fuzzing? Destroy everything? Oh shit. All right, what time is it? 6:22. Okay. In my defense, I said in the fucking title, oh God, short stream. Okay, it is gonna be a very short stream today. I got things I gotta do. But tomorrow, oh baby, you guys are eating good. Tomorrow is your guys' day. Okay, not that background. Tomorrow is your guys' time, baby. It's gonna be me and you and a shit ton of programming, okay? 100% is kind of useless. You shouldn't have to test, I don't know, a function to get something. I disagree. I think I am a big fan. Okay, just like how I'm a fan of the, you know, always auto lifestyle, I am a really big fan of 100% testing, okay? You know what? I'm gonna say something controversial. I'm gonna fucking say it, chat. I think that if you can't 100% test any application, you have functions that don't need to exist. There, I fucking said it. You need to start deleting functions, motherfucker. You gotta test everything, okay? Especially in today's era of like hyper focusing on cybersecurity and stuff. I don't know. I mean, okay, but let me put it this way, chat, because I don't know the level of standards in like industry or anything. I just make video games, right? I'm a fucking moron. Is this, I mean, I'm not gonna say this is 100% tested, but like in terms of percent, what am I at now? I'm at like 0, right? Because we haven't actually tested this. It's not a measure of like how much tested it is, just a measure of how many functions have like proper testing going on, right? I'm at 0% right now, right? Because I haven't like fucked around with this at all. If you like auto, why does your main not take 2 autos? You son of a bitch, you're right. How dare I? You're so fucking correct. Wait, does that even work? This is a pointer to a pointer, right? I can't auto this unless I do something stupid like this. No, it doesn't work. It doesn't work, chat. Can I auto pointer? No, I can't. Ah, shit. Can I auto that just super obnoxiously? Dude, if this was auto arg C, auto arg V, I think I would actually cry of happiness. I'm convinced nobody has this shit memorized, by the way. You all make this up, that you know argument C, argument V as like off the top of your head, all right? I don't believe you. I don't believe you, all right? Auto on the parameters would make it a template function. Can main be a template? Ooh, why not? It can do auto point to int. Oh, I guess it's not really the same. Wait, does this even work as is? No, it doesn't. Okay, it crashes. All right, fine. We'll be monsters and not put main as a template. Also, can I just say, what kind of, okay, I'm gonna be honest, chat. I don't know how you people lived going with like, what did you guys do back then? Int, print value, int x, and then do whatever, right? And then float, print, value, float, x. No, you wouldn't even do that. This is void, right? I don't know how you people lived like this. What did you do with your lives? Print, value, double, x. Is this what you people did? What kind of monster lived without, I think if I had to do this and never use templates, I would actually kill myself. That's a nightmare. And then you morons had to go template, fucking a class T. I don't know what the fuck you people type in this. Class T. And this is TX. I think that's the syntax for it. And nowadays, okay, even fuck that. Auto. Oh, it's so good, chat. It's so, I'm eating like a king. Templates were in C++, I think, for its entire lifetime. Well, then why do people care so much about overloading functions, you know? Do you use argc or argv? If not, auto main void. Oh, Studer, I do use them. In fact, here, I'll show you. If we were to replace this with void, watch. It crashes. SDL, the library, relies on you having these two things existing in it, especially for like cross-platform stuff. Templates are different than overloading. Are they though? Templates is a code generation tool. Overloading is for boomers stuck with the C mindset. Exactly! Chat, you know it. C++ is fantastic until it takes care of its dumbass older brother who just refuses to get a job, okay? This is so not pretty, but it only exists because we're using a C-based library, okay? That's the only reason that is the way it is, okay? Just, man. Imagine if they made C++ and did not give a fuck about like old school for loops. Who even uses old school for loops anymore? You use ranged for loops. So like auto, L, fucking my vector, whatever, right? And then you have your code, right? But even if you need to like iterate, there's still like standard, fuck, what did you use for iterating through a ranged for loop? Yeah, I'm not even close with like iteration something. Anyway, there's a way to iterate through that without using a regular for loop. And man, once I found that out, I don't know if I can ever use a regular for loop again. I'm gonna be totally honest. I don't know like why you ever would. Anyway, we're getting way off topic. There are uses to regular int. There's uses and then there's readability, all right? Is there really any case a regular for loop benefits more than like an anonymous function or a ranged for loop? Like, why not just use an anonymous function at that point if you're really that desperate? Things regarding having to jump forwards and backwards. Bitch, motherfucking, hold on, I'm gonna draw this out. Where's notepad? Give me notepad. Format, font size 144. There you go. Bitch, lambdas, all right? Sorry, that was funnier in my head, and I'm just not that good of a streamer yet. Okay, anyway, all right, way off topic. All right, we've initialized the program. We are now done. Tomorrow, we're gonna do basic game loop. So, you know, like run the don't like what you guys see here. Let me do this. Boom. In one frame, it created the window and then instantly destroyed it because we didn't tell it to keep it alive, and then we just exited with code 0. So tomorrow, keep the window up, super basic game loop. We're gonna start the event system, and we're gonna have a lot more time after that because it's gonna be a long day, but first triangle tomorrow. What the fuck, Blub? How do you know? So one of the new features of SDL3, if you guys don't know, is you are no longer constrained by rectangles. You can draw vertexes, triangles. So we're gonna use vertexes to draw something. With only triangles, we're gonna make something exist. That's gonna be probably what we do tomorrow as well, because we're gonna have a lot of time. I'm gonna stream for like 8 hours tomorrow, chat. It's gonna be a long day, but today is a short stream, okay? If you guys don't know, I stream every single day, and that's gonna be the plan. Tomorrow, we're gonna stream for like 8 hours. We're gonna have a game loop. We're gonna draw with triangles using vertexes. Is there anything else a new person to SDL3 would want to know? Yes, renamed functions. Holy shit, there's so many renames. Render texture is probably gonna be the biggest difference because no longer do you have to specify between int and float values. SDL just knows now, thank Christ. And if you wanna rotate, it's rotate, right? Rotated. No, it's not. Fuck, what was it? SDL render texture rotated. Oh, I was right. Yeah, so render texture rotated. So that's how you would rotate the triangle. And we're gonna use SDL vertex to have object types. Oh, it's gonna be so exciting. Sometimes it is important for some parsing problems, I believe, to jump back spots and forward. Maybe. Including things like an emulation where you might have a jump forward, backwards, and continuous memory. Okay, to be fair, when you open the emulation, when you whip out the emulation dick and just smack it on the table, it's like, okay, obviously C/assembly is gonna be the king, but like, we're not emulating here, okay? We're drawing dinky triangles on the screen for new people, all right? Let's not pull out the card, all right? All right, anyway. Tomorrow, we're gonna have a game loop. We're gonna draw super basic triangles. We're gonna make an object type of those triangles and like rotate it. Like that would be, but then you're introducing trigonometry. Maybe we won't go that far, but we need to rotate like 90 degrees or something. Well, no, that wouldn't be trigonometry. Maybe if it was smooth, but we could just say rotate 45 degrees and it would just do that, right? Yeah, I don't need to give you guys trigonometry. Fuck that, you guys can do that on your own, okay? We'll just keep it super simple, not mathy. It's gonna be fun. God, these statements are so long, I just can't stop looking at them and how ugly that is because we have to fucking babysit dumbass C-based libraries. Actually, it's not dumbass. I love SDL, okay? I love it with all my heart, but god damn, SFML sure can get tempting sometimes. Instead of standard move on line 32, could you not L data renderer, STD, whatever in line 27? Oh. Efficient. Oh, efficient. Look at that. Chat, you saved us like 1 CPU cycle there. Actually, it's probably more because we need to like move the whole unique pointer, but still. You might want to work on a wrapper then, make your own wrapper so you have to do this ever again. There will be 1, 2, 3, 4, 5, at least 5 more instances of us doing this. The top of my head, I can think of font being a big problem here because I don't know if we probably just have to create a function to do this, right? I don't know, maybe not. Because this is a function, right? Standard function, whatever. This is just an anonymous function, right? I guess I could make a function to do all this, but whatever. We might have to use a wrapper. I don't know. Also, you are correct. Thank you for pointing out we don't need standard move. Standard function is a function wrapper type. All right, anyway, that's it for today. All right, we streamed long enough. I gotta go do things. I'm sorry, I have a life. Tomorrow, can we get a different background? This one is depressing. Too weeb. Chat, I need new backgrounds. Oh, way too weeb. You guys are not ready for that one. Okay, no, you guys aren't mature enough. Nah, we ended on that one last time. There we go. Fucking pink hair lady, best wallpaper I have. Chat, I don't know if any of you have an ultra wide, like ultra wide monitor like I do, hence the black bars. But like this background, I think it's S tier. I love this background. See you all later, Stooter. All right, everyone, have a good night. Have a good evening. I have to do stuff. Give me licks. Tasty. I'll see you guys tomorrow. We're going to have a fun old time doing a game loop, and we're going to draw vertexes and triangles. Give me kisses. Goodbye.